Welcome to this episode of the CatBotAI Podcast. When Ken and I were formulating ideas that we wanted to discuss, we commented on the fact that we would do things that were kind of light and fluffy and also a little bit heavy. This specific podcast episode is a little heavy. It is about cyber warfare and AI. And Ken and I spent about 5 hours trying to record something until we threw our hands up in the air, and we are not subject matter experts. So we found one. His name is Nathan Mintz. And on this episode of the CatBotAI Podcast, we will be talking about cyber warfare. We will be talking about drones and AI. So just want to put a disclaimer out there that some people may find some of the content a little bit upsetting. Very knowledgeable, learned a lot. Just want to put it out there with all that's going on in the world. It may be an episode that could be potentially upsetting. Hi, everybody. Welcome to the CatBotAI Podcast. I'm your host, Catherine Brinkman. And today I'm with my sidekick, as I'm going to call him sometimes. Ken, say hello.
Hello, everyone, and welcome. My name is Ken. As Catherine mentioned, happy to be here today. And we have a very special guest with us who's going to be talking about a topic that Catherine will introduce here shortly.
Yeah, this is someone that I've known or going on like 22 years from their days at Stanford. They have 2 degrees from Stanford, maybe more. I might even be incorrect on this. But yeah, we have a local Californian on the call. We have Nathan Mintz today. Welcome to the show, Nathan. Thanks for coming.
Thanks, Catherine. Yeah, I think you and I actually first met, I want to say my sophomore year. Yeah, that was like Bobby Ela, Travis Mankin, those guys. Yeah, that was a long time, ancient history. Yeah.
Totally. Yeah. And things have definitely changed in that time. You're at the forefront of some very fascinating changes that are happening right now in defense technology. Full transparency for our listeners. Ken and I tried to really tackle this topic, and we don't know enough about it. And we're not subject matter experts. And as we got deeper, Ken, I think we actually spent 5 hours trying to do this back and forth. And
we did. Yes.
Yeah. Someone got like, I don't know what we're talking about. We can't do this first. And then Ken, like, I think an hour and a half later, you're like, maybe we need somebody. I was like, I know somebody. So Nathan, you're my somebody. And we really want to hear a little bit
more. You're nobody till somebody loves you. So, there's that. But
so you're co-founder of plethora of different companies. Today, I think we're going to be focusing on CX2. So if you want to do just like a quick intro of how did you even kind of really get into AI in regards to defense technology?
Yeah, well, I mean, maybe it would help if I started all the way back in the beginning. So I graduated from Stanford about 20 years ago. And my first job coming out of Stanford, my degrees were actually material science engineering, which I've done very little with, at least at the component level, since then. But I worked for Raytheon for about 9 years in systems engineering, radar systems engineering, payloads for spacecraft, electronic warfare systems. And then from there, I went to Boeing for 5 years, where I kind of did the same thing. I also worked on weapons programs. I worked on communication systems, et cetera, business development. And then about 7 years ago, an old friend of mine from Stanford, Joe Lonsdale, called me up and said, hey, we're interested in starting a defense vertical. I want to get back into defense. Joe, for those of you that don't know, had been one of the co-founders of Palantir. And so he called me up and said, do you have any ideas? And at the time, I'm like literally on the phone with him watching the TV, and an airport's being shut down in London because of errant drones, kind of like what's been happening in the news this week, right? It was Gatwick Airport. It was shut down for 25 hours, and it was just total chaos, and nobody knew what to do about it, let alone how to shoot the thing down, right? And so that got me thinking, and we came up with a plan to develop the technology for what would become Epirus, which is a high-power microwave company that does directed energy electromagnetic pulse to shoot down drones and drone swarms. So I was founding CEO of that, ran that for a couple of years, took it from idea to like 40-person company, got through the Series A, handed that off to somebody else. Then I took a break from defense, ran an automotive radar company called Spartan Radar for a few years, took that one through Series B, We just did a partial sale of that one to a big OEM. I can't get into the details, but that one's like all done now. The automotive space kind of like has had some hiccups lately, as you've probably seen in the news. A lot of layoffs, a lot of like delayed projects. Electrification is not happening as fast as people would like, et cetera. But still was happy to kind of get that experience and to see kind of like how fast commercial electronics were evolving and the role that AI and machine learning were having in perception and autonomous systems and all that. And it didn't take much imagination to see how that was going to bleed into defense. So about a year ago, I got together with a couple of guys. One was introduced to me by an investor, Mark Trefgar, my co-founder, who sold his company LiveRail to Facebook for $500 million. They do all the video sale backend. He did that a few years ago. And we started talking because we wanted to do something in defense. And then Porter Smith, who was a partner at Andreessen Horowitz at the time, and a former Army helicopter pilot, came in, and he'd spent months in Ukraine and said, hey, the face of warfare is changing. It's much more reliant on electronic warfare, particularly within the domain of how you defeat and protect, defeat your enemy's autonomous systems and protect your own autonomous systems, right? It gets into sort of C2 autonomy versus mission autonomy, which I can talk about in a little bit. But what we saw is an opening because the way that the U.S. was approaching the electronic warfare domain was really kind of an evolution of the same thinking that had gone on during the Cold War. We were still very focused on exquisite systems that produced effects from very far away that were meant to really defeat radar, what was called integrated air defense systems. Or conversely, to make our missiles shoot down the enemy aircraft, right? And they weren't seeing that like warfare has evolved, and now it's really more about networks and nodes in those networks and how you communicate with them and the autonomy of those nodes and how you're able to ensure your own systems can maintain command and control while denying it to your enemy. And all that occurs through the spectrum, right? So we came together and formed CX2. We had another co-founder, Lee Thompson, who joined us from SpaceX along the way. He did all the cool videos of Starship landing. That's all his communication systems that you see when like the fins about ready to fly off. So with that, we went out, started CX2. Actually, as soon as we signed the term sheet, we were in Ukraine for 2 weeks, kind of seeing how things were going on the ground. Ukraine, it's kind of hard to get there. You have to fly into Poland, and then you take a train in. There are these old Soviet era trains, and I can tell you that Ukrainian train ride should be an entry in Urban Dictionary. But it takes about 16 hours to get from Krakow to Kiev on these old 25-mile-an-hour trains. So we get there and kind of got to see, what they're dealing with on the ground. And the realization I had is that the U.S., we'll spend $4 million on an exquisite jammer to like defend an F-35 or something like that. These guys are spending $400 to $1,400 on some noise jammer to make it slightly less effective for an FPV drone to fly at them. And they're doing these by the thousands. And the scale of like drone warfare and stuff that we've seen over there is unprecedented compared to what we have anywhere, any time in history. It's really a paradigm shift in warfare. And the machine learning and AI layer that occurs in that, it's everything from automated targeting and automated targeting recognition, so that when the drone opens its eyes for the operator and says, I see something, the operator can say, yes, hit this. And then he presses the button and it flies in autonomously to, how does it continue to execute its mission when its command signal is jammed, right? And what sort of smarts does it need to have on board? And then conversely, it's the detection systems, being able to pick out these low, slow, small targets in very high clutter, super dense environments. You're trying to pick out a needle in a haystack without using massive amounts of power or massive amounts of money. So most of these systems, they're heavily leveraging commercial electronics, and there's a real spy versus spy that has occurred with them and the Russians. So we got to see that firsthand. It was pretty cool, and we're off to the races at CX2, building the U.S. spoiler to those systems. So how long did that take me? 5 minutes. So it was good intro.
All good. Fantastic. Thank you so much, Nathan. Just to kind of break that down, because you and I mean, I enjoy all the tech. I love that. But as we go into basically what your company does, and you've talked about this a little, one of the catch phrases or terms or mission statements is seeing the unseen in the electromagnetic spectrum. So could you unpack that a little for us, of those who aren't as familiar with that, and maybe share an example of how we can utilize, or how rather CX2 utilizes AI to turn those invisible signals into actionable intelligence that an operator could use, for instance?
Yeah, so when we talk about the invisible battlefield, we're talking about the wireless signals that provide intelligence, surveillance, reconnaissance about what's going on in situational awareness from various remote sensors. And then the comm signals that carry those, and how it all gets integrated into an operating picture. And everything that emits, or that even things that don't emit but are electronic, has a footprint in the electromagnetic spectrum, right? You have something called unintentional EMI, where electromagnetic interference, where even things like power lines and stuff can be detected at the right frequencies, right? And human beings, in fact, you can actually pick up a human heartbeat in the air. I don't know if you're aware of that. And
Oh, no.
there's a public release you can go look up. If you go look up heartbeat sensor and Raytheon, there was something that was built where they could detect a human heartbeat and debris, because there's an electrical signal associated with your heart pumping blood, right? And like the signals from your brain, and that is detectable. And you can actually detect it with Doppler radar as well. And like one of the things that we would do in automotive radar was detecting respiration and pulmonary response, because that allows you to say, is there somebody sitting in the seat or not? Which is
Mm.
important for things like, you know, airbag deployment and what angles you have airbag deployment at, things like that, right? In fact, or something as simple as being able to put a jug of milk on your seat without having the annoying weight sensor tell you that there's somebody sitting there that needs to put their seat on. It says no. That's or pet detection, person detection in cars. People leave babies in cars. Child presence detection, they call it. But getting back on track to your question, it's this invisible set of signals and emitters and networks that connect those emitters. That is the invisible battlefield. And the sheer volume of signals that exist, I mean, just to throw out one statistic from Ukraine, you have as many as 800 drones per square mile in the air at any given time.
Wow.
And that is beyond the capabilities of our Cold War era sensors to track. And you combine that with things like Bluetooth, cell phones, IoT, etc., and suddenly the signal density becomes too great for a human being to pick out on their own. And so there has to be some sort of machine intelligence that helps augment that person and sit on top of that haystack and help you find the needles of interest, right? And that's, I think, where a lot of the emphasis has been in Ukraine. That they have systems called SIGINT, or signal intelligence systems, that can pick that stuff out and say that, fingerprint it and say, this is a cell phone, this is Wi-Fi, this is a drone controller, etc. But they need to be um, teased out, and like have to understand the behavior of those particular nodes, how they interact with each other, and that tells you if they're hostile, they're friendly, or they're just there, right? Because like the other thing to kind of realize is that in a typical urban environment, I mean, think about in your house how many different Bluetooth enabled and Wi-Fi enabled peripherals there are in your house, right? Those are all emitting intermittently at any time, and you've got to pick that out in an urban or even a rural environment, be able to identify those and figure out what their intent is, which ones want to kill you and which don't. And that is beyond the ability of a human being to really juggle on their own. You get more than the number of tasks that you can or things that you can track on like two hands, and that's probably like more than a human in a stressful situation can handle. So it requires a certain level of AI and machine augmentation to sort out and to see the unseen and see what's important, and allow you to figure out how to both giving you the situational awareness to understand what's out there and what the whole common operating picture is, and B, decide which of those signals to attack.
Definitely. I mean, you kind of went into my next question too, and answer, which is fantastic. One thing I actually encountered in just to kind of bring this to a more at-home example as well is, you know what a TPMS sensor is for your tires, right? Well, I bought a TPMS sensor resetter. It would not work where I am. There's too much RF interference. It would not work. So I had to take it away from, you know, all the houses and everything else and get it to somewhere, and it worked just fine. So that's kind of the same instance you're talking about, that oversaturation of all those signals, and it just becomes noise, essentially, right? Yeah.
Absolutely, yeah, and it's structured and unstructured noise. And like one of the things we found out when we talked to the guys in Ukraine is that, you know, in the U.S. we worry about spectrum management, and I want to make sure that my jammer is not canceling your communication channel. We call that fratricide, right, or interfering with it. The Ukrainians, they just hand these jammers to the soldiers in the trenches like candy. You know, every third guy has a 200-watt jammer, and they're all going at the same time. And depending on if you're 10 feet above the ground or 30 feet above the ground, the EM environment's completely different, right? And it's just it's hell to deal with, right? It's kind of like Stalin's revenge. So the whole U.S. industrial complex since like the 1980s with the line breaker program that Bill Perry ran, which resulted in all the C2 systems and precision guided munitions that won the Gulf War. Has been about I want to use the optimal amount of force applied very precisely to handle this. 21st century warfare has been Stalin's revenge. Stalin said that quantity has a quality all of its own. That's exactly what we're seeing here, is that people are just trying to overwhelm you with masses of drones or jamming or anything like that to deal with the situation, to overwhelm the enemy. And that's sort of like become the mainstay of the digital battlefield of the 21st century.
Absolutely. And a lot of people don't think of that too. And of course, you have the other side using maybe not similar, but or similar technologies where they're trying to get through these signals and identify which are friend, which are foe, which is someone trying to jam. As you said, the jammers are just everywhere on the ground these days, right?
Yeah, so the U.S., our electronic warfare enterprise was heavily built around what was called intelligence preparation of the battlefield, which was basically this idea that the Russians or later on the Chinese or the Iranians or whatever would have a lot of these high capital assets that we want to defeat to, again, drop that precision guided bomb on whoever's making the decision and basically disrupt the network, right? Those systems that we have are exquisite. They fly on hundreds of $1-million aircraft with names like Rivet Joint, Compass Call, or we have a standoff jamming platform called Growler that I worked on earlier in my career when I was at Raytheon. We worked on the jamming pods for that. Those systems are really designed to fight at standoff ranges on these very low density battlefields looking for specific emitters of interest. They're not really designed to handle thousands at once, right? And that's what we're faced with, is thousands at once at the tactical edge with systems that aren't necessarily connected through command and control. And how do we deal with and address that, right? And the EMI and jamming environment that's associated with that. And we wrote a piece for the Wall Street Journal a couple months ago called The Future of Warfare is Electronic, that kind of went into this a little bit, talking about how some of our friends in Ukraine, they're sitting up there and they're trying to geolocate a GPS jammer, and they're saying that you can't do a damn thing in this war until you figure out the jamming, right? So it's while we were building these big strategic assets to handle going after their high capital assets, the Russians, the Chinese were building lots of tactical EW systems that could provide, could jam GPS on the battlefield. They could jam, start looking at jamming drones. And they've also been building these low-cost systems, right? So like they were much better prepared, both from a doctrine standpoint, from a kind of a capital standpoint for the sort of fight that they had in Ukraine. And a lot of our soldiers went, oh my God, where are our systems? And I'm happy to say the US is slowly getting there, but we're not all the way there.
That actually led me to a question. I mean, if this is new, when you think of your ramp up, if you were there, like what, since Ukraine war, that was like 2 years, you were there like a year ago, you said, what's been the biggest challenge to get ramped up?
In terms of CX2 and the company?
No, just in terms what you've seen so far. Just if you have, I'm thinking 800 drones per square mile, like that, that's overwhelming, completely overwhelming. So how have you been able to, I guess, with CX2, how have you been able to ramp up quickly? And then also everything's changing so quickly. How are you staying ahead of the game?
Yeah, well, I mean, I think so. Part of it is the U.S. military-industrial complex is built up around fielding and deploying exquisite systems that will work for 30 years and that will have a tactical or strategic advantage over our adversaries for that time. That drives more higher performance requirements, which drive cost and drive schedule. So that's why we're always over budget and we're always late. And we usually end up fielding fewer of a system than we think we would. I mean, so like, for example, a lot of people don't realize the B-2 bomber, we were supposed to have like 200 of them, right? We have 20, I want to say there's like 23 of them or something like that. There's a couple that have crashed. And the reason is that the aircraft were originally supposed to cost, like 200 million a piece, and they were projected to cost like 600 million a piece. And then when they cut the size of the program, it actually went to 2 billion, right? So because suddenly the NRE is like shared across fewer units. So and like the F-22 was the same thing. It was supposed to be 100 million a piece. It's 337 million a piece, right? And so on and so forth. And so you end up with these massive trillion-dollar systems. There was actually a former CEO of Martin Marietta named Norm Augustine, who had this thing called Augustine's Law. Or Augustine, he had a set of laws, but I think the one that's the most famous is that in the year 2050, the entire Department of Defense will have one aircraft in its inventory. For 3 days, it'll be flown by the Air Force, another 3 days by the Navy, and then the Marine Corps gets it on Sundays every other week or something. So like basically the idea was just over time, the cost of these systems was getting exponentially higher because performance was higher, right? And part of that's driven by like a need for there's a parasitic cycle of we need more reliable systems that are higher performance. So that increases costs. So we get fewer of these systems, which means that they really have to work more. So they end up needing to cost more and have higher performance. It just turns into this doom loop, right?
Yeah.
And the only way to break that is to relieve those requirements and say we're going to distribute the capabilities, right? So if you look at like what's happened in terms of the commercial space in the last 30 years, it's been going exactly the opposite direction. We've been going from extremely expensive mainframe computers to computers that you carry around on your phone or your wrist. And that was led to something called Metcalfe's Law, right? Metcalfe's Law says that the value of a network is equal to the square of the number of nodes in it, right? And that's really what's driven things like the proliferation of social media, of e-commerce, all these other things. This idea that value is derived from the network and the connections within the network rather than the individual nodes itself, right? Defense has been slow to wake up to that reality, but it is now waking up to that reality, which has caused a change in the paradigm of acquisition. So we've gone from building extremely exquisite systems to we're now looking with the effort is kind of classified as something called mid-tier acquisition reform, which is a fancy way of saying build simpler stuff with looser requirements, cheaper and in higher quantities and faster. And then so they've kind of started to break out acquisition into 3 categories. You have exquisite systems, which is the legacy systems, and you're always going to have a few of those. There's no way around it. You still need aircraft carriers. Or 5th generation stealth fighter jets. You just may need 2,000 instead of 3,000. Attritable systems, which is sort of the couple 100,000 to 10 million. That's your larger drones, et cetera. And then expendable systems, which is more like munitions or ordnance, right? So what we've been focused on at CX2 is how do I build more of those expendable systems for electronic warfare that cost low hundreds of thousands of dollars and can be built at scale, right? So the hard challenges of that sorry to kind of give you the long answer to your short question.
No.
The hard part of that is A, finding the talent to do it, B,
Right.
building out the supply chains, particularly with US compliant parts, and then C, getting the software to mechanize it all, which is kind of where the AI ML layer comes in, right? With large language models and things like that.
Mm-hmm. Absolutely. Speaking of AI, that brings up a good point. So we're essentially going to be having, hopefully, as many drones as they're using in Ukraine, if not more, in let's say a scenario that we have. As far as the AI goes, let's say they are also using electronic warfare and they have on their side an AI too. So is this like a real time, you hear about this when it comes to network penetration tests and all that, where the two AIs will essentially try to combat each other? Is that kind of a similar battlefield situation you might encounter, or is that still science fiction?
Yeah. So it is increasingly happening. So the principle kind of that you're alluding to, the Mad Magazine called it spy versus spy, or John Boyd, who's a military theorist who was very popular and read in all the academies, called it the OODA loop, or observe, orient, decide, and act. Right, and it was the idea that that in any situation, you and your adversary both have this OODA loop, and he who wins is the one who's able to turn in it faster than the other one, or prevent the enemy from turning in his. So a lot of electronic warfare is based around this idea of, that we call it the 5Ds: deny, delay, degrade, deceive, or destroy. Right, is based on, how do I get into that OODA loop and do those things to my adversary, or prevent them from doing them to his. Right, and what AI does is it allows you to basically set up independent agents that do each of these activities within that loop, without needing to bring a human into the loop. Now, some of these things are already done automatically without machine learning or AI. A lot of jamming techniques have been pretty automated for about 30 years. We had the introduction of something called a DRFM jammer in the 80s, which stands for digital RF memory, where basically the jammer would fingerprint the incoming signal and then do something to it to make it seem like it was either a lot more targets or it was flying away or something, and then send it back to the enemy radar. Right. That was kind of the first generation of that, sort of what we call rules-based AI. Right. That worked for a lot of what's called non-cooperative target recognition systems as well, where they would basically be, applying certain rules. If it's this long, it's this type of target. If it's this short, it's this type of target. Right. The next step that went in was the introduction of neural networks and machine learning. Right, and the idea that, okay, you can train a network to look at hundreds or thousands of data samples of a particular, whether it's a signal or a picture of an object or a radar image or whatever, and based on that, it can then apply. It can take inductively take that set of images, train and tune a model that can then apply that to the more general case of anything coming in and say, yes, that is a T-84 tank, and I know because I've seen thousands of images of it, and it's just in a different context, right? So that was sort of second wave AI. Now, what had been anticipated about 10 years ago, DARPA started working on something called third wave AI, which was AI with context, right? The ability to suddenly, take into account multiple inputs from disparate sources and kind of apply machine common sense, right? Because that's something that most AI, as you guys are, I'm sure, no doubt aware, there's a lot of hallucinations. There's a lot of false alarms. There's a lot of, it classifies a cat as a goose or something like that, right? So applying, common sense based on context or other cues was a big part of that. Now, I think a lot of that got thrown to the wayside with the introduction of large language models and with LSTMs and all the other pieces that kind of came into place, right? That, in my opinion, we are living in third wave AI right now, and it was totally different from what the people thought it would be 10 years ago, which was more, how do I take networks of neural networks and put them together and weight them, which is kind of what an LLM does, but not really. It's much more intricate how it does it. It's billions of tokens. It's not dozens of models, right? So, how that's applied on the battlefield is that you're now seeing large language models, much as how the transistor started as sort of the base component that went into all these military electronics, the large language models are getting incorporated into everything from intelligence analysis to tactics generation to creating synthetic data, which can then be used to train ATR. I mean, the sky is endless. It's like having a workforce of 1,000 people sitting in the warehouse. In fact, it probably, I would say that the US breakthroughs in LLMs have probably offset the Chinese advantage that they were seen to have in AI several years ago. Because, like, you'll recall when Project Maven started 6 to 10 years ago, I'm sure you guys, I mean, I don't know if the listeners would be familiar with Project Maven. Was sort of the Defense Department's early foray into AI for warfare. And famously, Google canceled the contract because some of their employees had moral objections to working for DoD, right? And then it turned into the Joint AI Center, and Anduril was actually one of their first big customers, right? For that. So then, or big contractors that sort of took over for that. So at the time that Project Maven was started, people were freaking out because there were stories about the Chinese having 30,000 people sitting in a warehouse, scoring pictures of various targets and everything, and building these intricate models based on what they kind of the same way that we were doing it with Crowdflower and trying to help you find ways to pick out your cousin in a Facebook photo or something, right? You don't hear much talk about that anymore. Like they went from being like, oh my God, the Chinese are going to kick our ass in AI, and they're building all these networks of sensors, and they're using them for monitoring their population, to, when was the last time you heard about some Chinese LLM that was like kicking OpenAI or Gemini's ass or something, right? I mean, you guys follow the space every day, but I haven't heard much about it, right? So,
no.
Right.
I think, go ahead, Catherine.
No, I just said you're right. It's not a topic anymore.
Right. So I think like the LLMs and the AGI folks have kind of put us ahead, and then it comes down to the race to build out the data centers and stuff. And who can build up the infrastructure to actually put these models to use and utilize them well and stuff. And the Chinese have their own efforts to build GPUs and that sort of thing, obviously. One area though where they still have an advantage over us, and partly it's because they've taken commercial industry and pivoted it, is the drone space. And DJI is 80% of the drone market by volume. And they build, the Chinese build 8 million drones a year, 20,000 a day. And about 80% of them are DJI drones. The US, in contrast, we build 20,000 drones a year, right? So they have this massive scale advantage. Sort of in between, the Ukrainians will build 1 million drones this year, and the Russians will build about 500 to 700,000, I think, right? So, even compared to the near peer adversaries are our own allies, we're building significantly less drones. And the Chinese, there's a whole bunch of infrastructure that they've built up to ingest the data coming out of DJI, coming out of their autonomous cars that are built by BYD and others, and turn that into models that can then be used to improve their autonomy stack, right? Which gets into kind of mission autonomy, which is where I think they still kind of have an advantage for us over us in certain contexts.
Let me ask you a question then based on that. Sorry. My thought is if China and Russia and these other countries are building more, what's the rate of which the failure rate? If we're building, I'm assuming that we're building things that are much more precise and they last the 30 years you said. With Russia and China pushing so many out, are there more error rates on their drones?
The failure rate is higher for a lot of these systems, but they also just culturally will tolerate a higher failure rate.
Okay.
And so the fact that they're deploying it all, even with the higher failure rate, gives them a first mover advantage, right? So for example, most of the trucking fleets in China, they're now introducing autonomous trucking at scale. So you have companies like Pony AI, which also has a US presence,
right,
that are building out autonomous trucking fleets in China. Here in the US, they're limited to a small set of corridors, as you're probably aware, like Texas, for example, and
Arizona, yeah.
Arizona, right? I mean, California by law, the Teamsters pushed it through where you can't even do autonomous trucking testing in California, right?
Right.
And what that's done is our own regulatory political hurdles have gotten in the way of us advancing that technology more so than our ability to develop the technology. So, if you look at how many tens of billions of dollars were pushed into AV vehicles in the last decade in the US, it dwarfs what the Chinese have put in. But our threshold of safety for deployment at scale, and what pain tolerance we have for accidents and anomalies and stuff, combined with just these regulatory hurdles of you cannot have that here because such and such union, they claim it's safety issues, but in reality, it's somebody trying to protect their rice bowl, does not want it, has led to us falling behind, right? And the same thing happened with DJI. Actually, an interesting fact is that we had all the technology to build these FPV drones and stuff in the U.S. All these companies were doing it around the same time as DJI. The difference is that if you were a U.S. drone manufacturer, your pilots were required to have an FAA license to fly them. The Chinese were not. The Chinese just ignored it and went through a loophole and called it a toy. And so they were able to build out this whole industry in the U.S. as one of their primary customers, and basically beat the crap out of the domestic drone industry because regulation prevented them from scaling, right? Prevent us on the U.S. from scaling. So where the Chinese have an advantage primarily is that sort of thing, is that we can't get out of our own underwear from a regulation standpoint, and that's been probably our biggest hurdle. And you see that with on the AI side, the Biden administration tried to do the same thing with the executive order limiting the size of large language models, right? Who did that benefit? That benefited the incumbents. It's what is it that Bill Gurley says? He says that regulation is the friend of the incumbent, right? Regulatory capture is the friend of the incumbent, right? And so you saw who were the ones that were pushing for the executive order? It was OpenAI. It was not to slam my friends at Palantir. It was a lot of the folks who already were dominant in the space, Microsoft, not the new upstarts, right? Because they saw it as an opportunity to capture the regulatory, to have regulatory capture and to build a moat for themselves through government regulation, right? So that, in my opinion, our issues are not technological compared to the Chinese; they're political.
Okay. So in theory, they're easy to fix. In theory.
In theory. In theory, yeah. Anything that comes with regulation always has regulations attached to it, right? So you mentioned a little more bridging into that with the future, and what do you see happening, let's say for the US or even the world, in the next 10 years when it comes to this sort of technology getting involved in the battlefield, as well as the integration of quantum computers into that, which are a big issue right now with cybersecurity everyone's concerned about?
Yeah, so there's a couple threads here. Let me first start by defining kind of the terms here. So the battlefield that you're seeing in Ukraine right now is primarily one focused on C2 autonomy. You still have a pilot with FPV goggles sitting there, and it's a 1v1 scenario. You have one pilot guiding one aircraft for the most part, or one drone, or one unmanned ground vehicle. That's another thing that we've started to see, in unmanned surface vehicles. In fact, the Ukrainians have basically won a naval war with no navy, because they have these unmanned surface vehicles that are basically, long-range torpedoes that can seek out and sink Russian ships. Okay, and with that, they've managed to pretty much cut off the the Black Sea there. Not a geographer. And then on the ground side, you're seeing a lot of the logistics being done by robots on the ground that are doing things like bringing supplies out, more batteries, more food, more water to the soldiers in the trenches. They're evacuating wounded from the battlefield. They're laying landmines. They're tripping landmines and clearing minefields, right? So we're starting to see the introduction of more of these autonomous systems, but it's still in the form of C2 autonomy. There's still a human being there. It's remote controlled. It has some local control that kind of provides balance and stability and stuff. The pilot isn't manually working every control that's all stabilized. The next step is what we would call mission autonomy, which is where basically you give high-level instructions, fly to this point, look for this type of target. If you see it, report back, and I'll give you permission to strike it, etc. That gets into the realm of what's called loitering munitions. There's a couple of U.S. companies that do that. Probably the most famous is AeroVironment, as well as Anduril. AeroVironment builds the Switchblade, which was first deployed in the first part of the Ukraine war. But taking it a step further, where there's one human being and he's launching 100 of these things, and they're really only checking in with him for higher and higher level commands. Okay, when you have that, it introduces, and this is where the electronic warfare component comes in, the potential for adversarial networks, which is very much a big problem for training data, right? You see somebody that comes in and says, okay, well, if I load the model full of sociopathic things and shit posting, then no one's going to want to use it because the model's going to be crazy, right? And we've seen that kind of happen with like chatbots and other things like that, right? Well, the same thing can happen with autonomous systems, where if you feed it a whole bunch of false information, it's like Wile E. Coyote. When the Roadrunner paints the tunnel on the wall, and he just drives right through it because he doesn't know the difference. The same thing can very easily happen with autonomous systems, depending on their level of sophistication. So you're going to start to see more of that type of thing happening. Is the introduction of adversarial networks. Combined with that, you're going to see higher and higher levels of scale of autonomy, where one human is controlling 10 drones or 100 drones or 1,000 drones even, right? Or you have these autonomous networks that just kind of sit out there and they have a whole set of jobs that they crunch through, right? And then the question becomes, okay, well, you asked a question about quantum computing and how does that fit in there? Well, it's still very early with quantum, and I think Google, with what was the chip that they just introduced? The name's escaping me.
Willow.
Willow.
That's what it is.
I mean, that's really cool that they have it and all, but people are still trying to figure out how to program it. They're still trying to figure out the application use cases. That's wonderful. They figured out the physical layer, but there's 7 layers above it that need to be figured out first, or before it can turn into a commercial product, right? That can be used at scale. So I think we're a few years away from seeing that fully play out, maybe 10 years. The main advantage of crypto is that suddenly everyone, or of quantum, is going to be suddenly everyone needs a quantum computer of their own to protect their own encryption, or else it's going to crack their code. So it's going to make every form of encryption and frequency hopping and stuff probably obsolete overnight. In the same way that stealth kind of made a whole generation of radars mostly useless, right? It'll probably have a similar analogy there. But I think we're a few years away from that. The big issue will be how does it work at the tactical edge? I don't know about Willow specifically, but I actually have a small investment in a quantum computing company through one of the funds that I'm an LP in. And my understanding is most of these systems have to be cryogenically cooled, down to liquid helium temperatures. So that's not horribly practical on the edge of a battlefield.
No.
And a lot of this is going to come down to how do you deploy machine learning and large language models at the tactical edge under what's called DDIL conditions, which is denied, degraded, intermittent, and low bandwidth, where the enemy's trying to deny you access to your own network. So until they solve that kind of scaling problem, you're probably not going to see it used too ubiquitously. And then you also have the problem of, there's always kind of a reluctance to throw down anything like that, because once the enemy sees your card, then they're going to start developing a countermeasure immediately. And so that will also delay kind of the emergence of those systems and the deployment.
Absolutely. Well, and just to kind of brace into that and what's happening in the future there. So for some of our listeners who are fascinated by this, because I know I am myself, in fact, I'm going to be looking up some of the stuff you mentioned as well, because I'm not as well versed in it as I'd like to be. What do you see if they want to learn about where the technology is heading, where it's at? What's one key trend or innovation that they should have on their radar, so to say, for the coming years?
Yeah, I would say it's this mission autonomy, and it's increasingly the ability to translate high level human commands to specific tasks that can be decomposed by edge computers and then turn into tasks for unmanned autonomous systems. Right. That is where I see things going, and you see that with what's getting funded right now. It's Figure just raised $600 million. I mean, Tesla came out and said their future is Optimus, not cars. Right. You're seeing them kind of go this, and aside from the fact that it looks like a human and it's like Mr. Data that we all grew up watching on TV and stuff, right? Or C3PO, or take your pick. The real advantage that I think people see is that they're able to anthropomorphize better. The idea that I'm going to give this guy commands in English the way I would a person working for me, and then they're going to decrypt it, as opposed to very specific lines of code that I have to use, sequential instructions to get it to do, a fairly low level task like fold my laundry, right? And actually brilliantly, my buddy Joe Lonsdale, I think you could still find the talk on TEDx somewhere. He gave a talk about 15 years ago talking about how abstraction is the mega trend that's occurred in the last 25 years of technology. And Palantir was kind of the first level of that, of how do I get abstraction from big data into salient knowledge that I can then use to create actionable intelligence, whether that's to unpack a terrorist network or to find the source of all of my spend in a month is really something I didn't expect, right? Like they use it for financials, they use it for and in healthcare. Palantir and big data tools are used all over, pretty ubiquitous now, right? So you keep going up these levels of abstraction to where suddenly you're telling computers to do things in the same way that you would a human, or maybe even with less knowledge than a human has. I mean, that's sort of when we talk about the singularity and this idea that computers could act with more intelligence than humans could. I think that's the big mega trend to kind of follow. Is how do we, and you're seeing this with coding co-pilots and other things, and the battlefield's no different. In fact, I would say the big kind of difference is that 80 years ago, it was military technology that was driving the commercial sector. And we saw that with the introduction of the jet engine and the space program and all these other things that, allowed us, they gave us, coast to coast flights and gave us, the global supply chain and computers and all these other things. Well, now the commercial sector dwarfs the military sector. And so any innovations that occur in the military sector are primarily driven by commercial demand, at least on the electronic side and the software side. So that's kind of the mega trend I would look at, is the abstraction and how that's going to play out. And you can kind of apply that thought exercise to any domain.
This is a lot, Nathan. Thank you. This is a lot. This is
a lot to unpack. Yeah.
A lot to think about. Glad that you are here. Thank you for doing what you do. Seriously, now I have even more things to think about and be like, dude, what's happening?
Yeah.
So thank you
Kat,
for.
If the users are interested in specifically what we're doing in CX2, in terms of suppression of enemy emitters and networks and stuff, destruction of enemy emitters and networks, they can go to our website, cx2.com.
Perfect.
I also write a Substack called Bow of Theseus that they can check out, that I go into in depth on a lot of these topics. I also talk about some of the commercial AI stuff and what have you. And they can feel free to check those out as resources.
Cool. We'll put it in the show notes for sure. Thank you.
Yeah.
Thank you so much for being a guest. We appreciate it. Thanks for, again, seriously, doing what you do. It's very important, especially now. And also explaining, when you start to think about the three that are not our friends, the way that you explain it in regards to we're not that far behind. We're not that far behind. Some areas we might be we're a little more ahead. At least we know now. Do you know what I mean? Like,
Yeah.
if we didn't know
Where
2
we
years
are,
ago.
I mean, I'm an optimist by nature. I mean, I'm a realist, but I'm an optimist. And I would say that like where we're behind, it's our political and regulatory structure that's getting in the way,
Yeah.
not our desire to build, or not our competence with the technology.
Right.
Like the good thing is that, I mean, in some ways the political and the human barriers are harder to solve than the technological ones, but that's really where people have to think about it in terms of like, if we want to catch up to the Chinese in the drone game, we got to change the way that like the laws are written so that there can be more commercial drone production here in the US, and that we're not hamstringing ourselves with like stupid outmoded requirements that were like meant for, remote control aircraft pilots 80 years ago, or like how the FCC allocates spectrum is like 100 years old, right? So
Yeah.
we have to break down some of those regulatory barriers, and maybe it's something for Doge to think about. I mean, I hope Doge is thinking about it, so rather than just shit posting and breaking the budget.
So many more questions.
Love it.
I know we have reached our time. Want to make sure that we're respectful. Nathan, thank you again for being here. And we will post all the information. Ken and I have our due diligence to go look up some of these things that you commented on. We'll put it in the show notes for our listeners and our viewers. And on that note, thank you so much. Appreciate it.